Hi everyone. The purpose of today's video is to prepare you for an in-class discussion on graphs as covariation. So I will be going over some basic prerequisite knowledge that you need to have about graphs and graphing. First, let's ask ourselves, what is a graph? Well, a simple way to define a graph is to say that it's a visual representation of statistical data or a representation of a functional relationship between variables. Now you might be wondering, what is the purpose of graphing, or why do we use graphs? And the answer to that question is that we use graphs to show how quantities covary, or in simpler terms, we use graphs to show how quantities change in relation to each other. Now let's dive a little bit more into graphs. So a graph consists of a horizontal line, known as the x-axis, and a vertical line, known as the y-axis. Most of the time you'll see a graph that looks like the one in figure 1, but you may also come across a graph that looks like the one in figure 2. In figure 1, the graph shows only the positive values of the x and y axes. However, in figure 2, we see a graph that is divided into 4 sections. These sections are called quadrants. The first quadrant has positive x and y values, the second quadrant has negative x values and positive y values, the third quadrant has negative x and y values, and the fourth quadrant has positive x values and negative y values. Now moving on, let's see how we can actually graph a set of data. So say that you were given a table of values representing the relationship between the amount of time a person spends studying and the number of questions they get correct on a quiz. To start graphing this, you would label the x-axis as the time spent studying in hours and the y-axis as the number of correct answers on the quiz. Then you would label both axes using equal increments. After that, you locate the first x value on the x-axis, which is 0 in this case, and from that point you locate the corresponding y value, which is also 0, and that's where you plot your point. Then you do the same thing for 1, 2. So you locate 1 on the x-axis, and from there you go up to locate your y value, which is 2, and that's where you plot your point. You continue to do this until you've plotted all of your given values and you end up with a graph like the one you see here. Now let's say that we were just given the graph and asked to analyze it. By looking at the graph, we can still see the linear relationship between the two quantities. So the more the person studies, the more correct answers they will have on the quiz. So now that you have a solid understanding of this prerequisite knowledge, I would like you to think about the following things in preparation for our class discussion. First, I would like you to ask yourself if it is possible to have graphs that represent relationships other than a linear relationship. If you think it's possible, try to come up with an example. Also, I would like you to think about how the area of a triangle is affected by an increase in the length of its base, and try to see if you can come up with a general graph for this relationship. I hope you found this video helpful. Thank you for watching.